Hello everyone. So my topic is about memory management, swapping and contiguous memory. What is memory management? Memory management is the process by the OS which allocates, tracks and controls the computer's memory so that programs can run efficiently without interfering each other. It is the most important function of OS. It helps processes to move back and forward between the main memory and execution disk. It helps OS to keep track of every memory location, whether it is allocated to some processes or it remains free. It is a critical function of OS that manages primary memory to optimize overall performance. It ensures stability. Also, it allows multiple applications to run efficiently at the same time. What is functions of memory management? Memory management allocates memory to processes when they need it. Also, it deallocates when they are finished, which makes memory available for other users. The operating system keeps a track of every memory location, whether it is currently in use or by a process or if it's free. It ensures that each process operates in its own dedicated memory space, preventing interference between programs and improving security. Effective memory management prevents issues like memory leaks and fragmentation, which can slow down a system. So it also optimizes the performance. And techniques like paging and swapping are used to create visual memory. This also make use of um, it also used in memory management. These are the functions of memory management. Now let's talk about swapping and contiguous memory allocation. Swapping and contiguous memory allocation are core techniques used in memory management. What is swapping? Swapping is a memory management technique used by OS to manage limited RAM more efficiently. Swapping is the process of moving a process between the main memory and the secondary storage. When RAM is full, the OS swaps out an inactive process from RAM to the swap space on disk. Okay. When that process is needed again, the OS swaps it back into RAM. This helps the system run more program than the physical RAM could normally support. Now let's talk about how it works with an example. Imagine there's a small table in your room and you can keep only few books on the table at the same time. And you have to place a new book. What would you do? You would probably do that. There is a book that you are not currently reading, and you would pick that and put it back, put it back to the shelf or somewhere, and you would put that new book on the table, right? That's exactly how swapping works. Okay. Now let's talk about its uses. It uses to increase the multi-programming level, also prevent the system from running out of RAM, also keep active processes running smoothly. Swapping is a slow process, okay, because this access is much slower than RAM, and if too much swapping happens, it makes the system slow. That is when we call the system is trashing. Okay. Now let's talk about contiguous memory. Contiguous memory allocation is a memory management technique where each process is given one single continuous block of memory in RAM. It means that OS allocates memory to processes in one continuous chunk so that all memory addresses for that process are adjacent to each other. Okay, when a new process comes, the OS gives it a block of side-by-side seats. So it that is why it calls contiguous memory allocation, which means they are all allocated memory are allocated in next to each other. Okay, that is why it is called contiguous memory allocation. So in contiguous memory allocation, there are two parts: single partition allocation and multiple partition allocation. In single partition allocation, memory is divided into two parts, one for OS and one for user processes. In this, only one user process can run one time at a time. Okay, so this single partition allocation is not currently in use. The multiple partition allocation is currently in use. In multiple partition allocation, it is divided into two types, fixed partition allocation and variable partition allocation, also called dynamic allocation. In fixed partition allocation, memory is divided into fixed size partitions. In dynamic partition allocation, memory is divided in dynamically based on the size of the process. Okay, now let's talk about features of fixed partition allocation. Fixed partition allocation, each partition holds exactly one process. Some partitions may empty or unused. Okay, and fixed partition, dynamic partition features are there is no fixed partition sizes. Okay, process get exactly the memory they need. The problems of fixed partition and dynamic partitions are internal and external fragmentation. The main problem of contiguous memory is fragmentation. Okay, so contiguous memory allocation often needs swapping because when a memory is full, OS swaps the process out to create one large continuous block. Swapping helps free up a continuous space for new process. Okay. So now let's conclude this topic. Memory management ensures efficient use of RAM and smooth execution of process. Swapping helps increase multiprogramming by moving inactive process to disk when RAM is full. However, swapping can slow down the system due to heavy disk usage. Okay. So contiguous memory allocation is simple and fast because processors receive continuous memory blocks, but it suffers from fragmentation, as I told, external and internal fragmentation. Okay, which reduces memory efficiency. So together these techniques helps the OS manage memory effectively and maintain system stability. Thank you.